Chapter 3, Section 5, Parallel Lines and Triangles. So the first postulate from this section is the parallel postulate. Through a point not on a line, there is one and only one line parallel to the given line. So there is exactly one point. Let's say we have line L. And we have one point P. What this is saying is that there's exactly one line that can be drawn through P that will be parallel to L. In other words, lines coming in different directions through P are not going to be parallel to L. They're going to eventually intersect L. There's only one line that will be parallel to L and go through point P. 311 we've been talking about a lot lately, the triangle angle sum theorem. The sum of the measures of the angles of a triangle is 180 degrees. So if they give you that one angle is a right angle, one angle is 30 degrees, since we know that they have to add up to 180, 90 plus 30 is 120, so the other angle must be 60 degrees. Now a proof of this theorem, if it's given to us that we have a triangle ABC, and they want us to prove that the measure of angle A plus the measure of angle 2 plus the measure of angle C is 180. So they want us to prove A, so BAC, 2, and C is 180 degrees. Now a good way for you to show this proof on your own, if you cut out a triangle on a piece of paper and you cut off each of the angles of the triangle and then line them up so all of their vertexes are in the same spot. So in other words, if you cut out a triangle and then you cut off all of these angles and then take it so that all of the vertexes come here, when you line them up, you'll see that the angles add up to 180 degrees. So this is a good way for you to prove it yourself if you're curious. So our first step is just to write the given statement that we have a triangle ABC, and that's given. Our second statement is going to be to say that the measure of angle PBC plus the measure of angle 3 equals 180. And the reasoning behind that is that angles that are adjacent and add up to a straight angle are a linear pair. Linear pairs are supplementary, and supplementary angles add up to 180 degrees. Now that we have this, we can say that the measure of angle PBC equals the measure of angle 1 plus the measure of angle 2 by the angle addition postulate. So just like the segment addition postulate, but we're going to use the angle addition postulate to show what the whole angle breaks up into. So now by substitution, we can say that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. By the substitution property. After this, for step 5, since we know that angle 1 and angle A are alternate interior angles, we can say that angle 1 is congruent to angle A, and the same thing goes for angle 3 is congruent to angle C, because if parallel lines are cut by a transversal, congruent alternate interior angles are formed. So in the end, we have, since they're congruent angles, we can change them to equivalent, because angles which are congruent have equal measures. And then we can use substitution to come up with our final statement. Measure of angle A plus measure of angle 2 plus measure of angle C equals 180 degrees by the substitution property, and that would be the end of our proof. Now, this is one way to do it. This is similar to how the textbook does it, but I've made some changes for the way that we prove in class. There are things that you can take out, combine, replace, but this is how I'm showing it, but there are different ways. Now, the triangle exterior angle theorem is also a useful theorem. The measure of each exterior angle of a triangle equals the sum of the measures of its two remote interior angles. So you get an exterior angle by looking, if you extend one side of the triangle, this would be the exterior angle. If we were to extend the other side of this triangle, this would be an exterior angle. This is nothing. It's only when you extend the side, this is an exterior angle, this is an exterior angle. So each triangle, if you extended all of the sides, has 1, 2, 3, 4, 5, 6 exterior angles. So let's use this to do a few examples. Well, they're looking for the measure of angle 1 in the first example. So in order to find it, we know that the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3. So the measure of the exterior angle is equal to the sum of the two remote, meaning it doesn't share the side. So the two remote interior angles. So 46 plus 41 gives us 87. So the measure of angle 1 is 87 degrees. Now here we can work in reverse. Well, we know that the two remote interior angles, 53 degrees, and whatever the measure of angle 2 is, has to equal 119 degrees. We'd solve for the measure of angle 2, and we'd get that the measure of angle 2 equals 66 degrees. Now in this last example, we're looking for z, y, and x. Well, we know that in order to find y, we can add up the two remote interior angles. So 32 plus 46 gives us that y is 78 degrees. Now we can use the triangle sum, the angle sum theorem, to find out what the measure of angle z is. Well, 180 minus 78 plus 36 gives us 114. This leaves us with 66 degrees, so z is 66 degrees. And then we can use the triangle angle sum theorem again on the other side. 180 minus 46 plus 32 is 78. So the measure of angle x is 102 degrees.